Hello and welcome to the YouTube channel The Creations Resources. Today, while looking at some concepts from experimental physics, we are going to talk about the experiment of conversion from temperature to frequency. This is done using a multivibrator circuit and a thermistor. So the gist is the thermistor's resistance, which changes with temperature, is incorporated into the multivibrator's timing circuit, thus influencing the oscillation frequency. So the idea is, in this experiment there will be a temperature to frequency converter with a linear or near linear relationship between temperature and output frequency. So as expected, the core components are going to be a thermistor and an astable multivibrator. Let us talk about these individually and then continue. So what is a thermistor? So as you can see, the name is composed of two words, thermally changing resistor. So these are electrical resistors usually made up of metal oxides with semiconductor properties. So these are ceramic semiconductors and which show non-linear or exponential changes in their resistance with changes in temperature. So the measurement of resistance value of the thermistor will be used for temperature measurement. Different kinds of metal oxides can be used here for creating a thermistor. So it could be manganese oxide or oxides of chromium or cobalt or iron or nickel. The idea is these have to be semiconducting metal oxides. And usually these materials are chosen for their high temperature coefficient of resistivity, means that their resistance changes significantly with temperature changes. Now, the shape of a thermistor could be a bead or a disc or a rod, and they are often encapsulated in epoxy or glass for protection and to maintain their characteristics. Now there are two types of thermistors, NTC and PTC. NTC stands for negative temperature coefficient, where resistance decreases with increasing temperature, or PTC stands for positive temperature coefficient, where resistance increases with temperature. And usually, say if manganese oxide or nickel oxide etc. is used, it's a NTC thermistor, while usually if titanium compounds are used, it's a PTC thermistor. Now, in order to talk about a stable multivibrator, let us first talk about a multivibrator. So, a multivibrator is an electronic circuit that generates either a square or rectangular waveform. So, it's also called a non-linear oscillator or function generator. And it's essentially a two-state system that oscillates between two voltage levels, and it's widely used for generating clock signals or timing, pulse generation, etc. in electronic circuits. Now there are three types of multivibrators, namely astable multivibrator, monostable multivibrator and bistable multivibrator. Actually, the names themselves suggest you what difference there is going to be between these three. So an astable multivibrator, which is of course going to be of concern for us for the T2F experiment. Here the type is continuously oscillating, switching between two unstable states without any external trigger. And so it's used as an oscillator or a timer. We will talk about it in detail, but first let us talk about the other types, namely monostable multivibrator and bistable multivibrator. So mono and bi. So that tells you that in case of monostable multivibrator, there is mono, that means one stable state and one unstable state. So it requires an external trigger to switch to the unstable state, and it will return to the stable state after a set time. So it's often used as timer or pulse stretcher. Then bistable multivibrator. So this type has two stable states, and it requires an external trigger to switch between these two states, and it remains in each state indefinitely until triggered again. So the difference here is, in case of monostable multivibrators, since there is only one stable and one unstable state, so it requires external trigger to switch to the unstable state. but then it returns to the stable state on its own after a set time. But in case of bistable multivibrator, it requires an external trigger to switch between both the states. So it's also called a flip-flop or latch in digital circuits. So coming back to an astable multivibrator, it is a free-running oscillator circuit that produces a continuous square wave output without requiring any external triggering. And there are no stable states. That means the circuit will continuously switch between two unstable states, generating a repeating waveform. So that's why it's useful for applications which require a repetitive signal. Now, because it is continuously switching, it is also called as a free running multivibrator or oscillator. And the switching results in the square wave output. Now, the time period of each on and off state in the square wave is going to be determined by the RC time constants of the circuit components. So, resistors and capacitors. Now, typically it is built using two amplifying devices like transistors connected in a positive feedback loop. The charging and discharging of capacitors connected between the transistors collectors and bases drive the oscillation. And when one transistor is conducting, that is it is on, it pulls its collector voltage low. So which causes the capacitor connected to the other transistor's base charge. Now as the capacitor charges, the base voltage of the other transistor rises. When the capacitor voltage reaches a certain threshold, the second transistor starts conducting, that is it's on. And this causes the second transistor's collector voltage to go low, which in turn causes the first transistor's base voltage to drop, switching it off. So this cycle of one transistor turning on while the other turns off repeats continuously, generating the oscillating output waveform. So if you want to talk about its characteristics, first of all, very clearly no stable states, unlike the other types of multivibrators. So both the output states of an astable multivibrator are unstable. The circuit does not remain in either state indefinitely. And the circuit continuously switches between the two unstable states, resulting in a periodic output waveform. Typically it's a square wave. Now these astable multivibrators are self-triggering. That means they initiate and maintain their oscillation without any external trigger or any external input signal. And the frequency and duty cycle of the output waveform are determined by the values of the resistors and capacitors in the circuit's timing networks. To give a simple analogy, imagine that you have two friends who love to take turns doing something. So 1 minute one friend is doing it and the next minute the other friend is doing it. So that is how it is happening in case of an astable multivibrator, or you can think of two small switches. Okay, so when one switch is on, it makes the other switch turn off, and when the second switch is off, something like a capacitor charging up starts to happen, which eventually makes the first switch turn off. The moment the first switch is off, again this process repeats and makes the second switch turn on. And so it goes on back and forth, making the switches flip on and off continuously. So it's like blinking lights, like the ones on an emergency vehicle or even on some toys, back and forth switching action. Or in case of say buzzers, by switching a speaker on and off quickly. Or in timers or clocks where we are trying to time things accurately. And in case of an astable multivibrator, instead of the switches, you actually have electronic components like transistors. So here transistors are acting like tiny electronic switches, turning on and off depending on the signal. And when the transistors will switch is controlled by capacitors. So capacitors are like tiny containers that can store electricity, and they charge up and discharge. And this timing helps control when the transistors are going to switch. And how fast the capacitors charge and discharge is going to be determined by the resistors. So they are going to control that. So these are the two core components used in the temperature to frequency experiment, namely thermistor and astable multivibrator. We'll know about some more things in later episodes. Thank you.